Hello, welcome to this demonstration of the Costing Nature Ecosystem Service Assessment tool. Today we're going to be running a baseline analysis using the scientist level user interface, which is the free access level. So I have logged in as a scientist, as you can see here on the left. And the first thing we need to do is we need to select our area of analysis. And today I'll be running an area in Colombia. So I'm going to type in Colombia in the box here. I'll click on Go, and the map will center on Colombia. Now, Costing Nature can be run at two different resolutions. We can run it at 1 kilometer resolution for those big, large blue tiles, which are 10 degree by 10 degree tiles, so roughly 1,000 by 1,000 kilometers. Or we can run it at 1 hectare resolution, which are these 1 degree tiles, so roughly 100 by 100 kilometer. And the system will always run the tile that is highlighted. So if I move the map to the right, then this tile here will be run. If I move it to the left, this tile will be run. To set the resolution that you want to run in, you can select 1 kilometer or 1 hectare here. Now, before we can do a run, we need to give it a name. So I'm going to call this run Colombia, and I'm going to leave it to 1 kilometer because I'm interested in running Costing Nature for this whole area here. So all I need to do now is click Define Area, and now we will have set our run for Colombia. And you can see at the top here, it now says Run Colombia. If this doesn't change from whatever it was before, click on Refresh, and it will tell you what run you are in. Now, the next step to do an analysis on Costing Nature is to prepare the data. So I'm going to the left here and click on Step 2, Prepare Data. This will open up another window. And here we have a couple of options that are other user levels, so they're licensed. But we can copy the data to our workspace, or we can list the baseline workspace data. I'm going to click on Copy Data to the workspace straight away, and then we can have a look at the data once it's in our workspace. So what the system will do now is it will copy over the data from the Simterra data server into an area on the server that is linked to your username, so your own workspace, and the run will be done from there. So this takes no more than a few minutes. You can see what the system is doing by hovering your mouse over these little green blocks. It tells you how many are still left to do. Okay, so the system is now ready with copying over the data, and now it says data ready and show workspace data. So we click on the plus minus next to here. We can see all the data that is necessary to do a run in Costing Nature. All these locks here mean, as it says at the top here, that these are licensed data sets. So the data sets that can be visualized and downloaded from this list depend upon our licenses that we have with data providers, but also on the license that you have with us. Obviously, we're using the free scientist user interface, so there's not many maps that you can actually have a look at or download, but you can get information on the stats of the maps by clicking on these little sum icons. So show map stats. So for instance, the projected temperature change, so climate change. If I click on the sum and then hover my mouse over results, it gives me the mean change of 2.6 degrees Celsius. And you can do that for every map. So we can close this window now because we've set up the data. It's ready to do a simulation, so we can move on to step 3, which is to start the simulation. So I'm going to click on step 3, start simulation. And there is an option here to index globally or index locally. By default, it will be set to index the maps globally, and that will mean that all your outputs will be scaled from 0 to 1 on a global scale. And you can change that by clicking index locally here, and then your maps will be scaled 0 to 1 for the tile that you are running. So in this case, all the maps will scale all the way up to the value of 1 for this tile. And this is obviously very useful if you want to compare areas. So if you would like to run this tile and a tile somewhere else, and you want to compare them, then you should leave it to globally, which is what I'm going to do now as well. To get the simulation started, we just click Start, and the system will start its simulation. This should take no more than a few minutes to run a costing nature simulation. At any time, you can have a look and check whether you're in the right system. At the top here, it will tell you that we're currently using the Costing Nature version 2, logged in as a scientist doing the tile or the run called Colombia. You will find the same on the main page here as well. So the simulation has finished. It didn't take very long. So what we can do now is we can close this simulation control. We could have closed it before, because once you set the simulation running, you can close it. You can close the computer because the simulation runs on our servers. So let's close that, and we can now have a look at the results. And to look at the results, we're going to skip step 4 because that's a scenario, a policy exercise, and we're going to results step 5. I'm going to click on step 5 results maps. And that brings up all the output maps for Costing Nature. Now, there's quite a number of maps here that we can have a look at. By clicking on the green icon, we open up a map viewer, and here is an explanation of what the map tells you. So if we go all the way to the bottom, the services that are simulated by Costing Nature are water, carbon, nature-based tourism, and hazard mitigation services. So we can look at the relative total realized bundled services. So this will give us a map of these 4 services bundled into one, so normalized into one. So if I click on Display into your browse map, our map viewer opens, and every time you see an icon like this, this is the type of viewer you will see. So these are pixel-based values of your bundled ecosystem services. And because we set it to scale globally, as it says here, your values are not likely to make it all the way to 1. In this case, the highest we get is 0.1. There's a couple of options we have to look at this map and to change the map. So we can change it here by clicking on Change Image. We can set minimum and maximum. We can set the color legend. You can download the map in a number of GIS formats, and if you want to use the map, then the citation is down there. We can also have an aggregate map, so we can aggregate these pixel values over other maps by clicking on View By. This will open up a list of other maps that we can use to aggregate those. So for instance, we can look at the value by sub-basin. Hydrosheds data, for instance. And then your map will look like this. So this will take the average, the pixels that fall within these basins. So I'm going to close that. And underneath the map, we have more options to view So we can view this map straight over in Google Earth, Google Maps. We can pop out the map and we can get the histogram distribution of the values. Let's have a look at the view in Google Maps. Click on view in Google Maps. The map will open overlaid on Google Maps, as you can see, and we can switch it on and off here. We can change the opacity values. And then we can also query individual points. So I can drag the map around and move my crosshair here to the pixel or area that I want to have a look at. So for instance, we have high values of total realized bundled services here. So if I hover get my crosshair on those areas and I click on query, I can get the actual value for the cell that it's currently on, which is 0.4. And if I then click on inputs and the icon that appears next to it, query inputs, that allows me to look at the components that make up the values of this map. So because this is a bundled services map, the services that are in there are carbon, nature-based tourism, water, and hazard mitigation. If I show the values for each of these individual at the pixel where my crosshair is, I can see that the reason we have a high value for total bundled services is because we have high carbon value and high nature-based tourism, whereas the values of water, provisioning, and hazard mitigation ecosystem services are relatively low. So this is a way to get the individual values for the services that are included in the bundled services index. Close that now. And we can look at some of the other maps. So what we looked at was the realized services index, i.e. those services that are provided but also consumed by humans. We can also look at the potential bundled services. So let's open that. And in order to compare them, pop out this map, close the map behind it, and do the same for the realized services. Pop out this map, close it, now be able to see them next to each other. So on the left here we have the relative potential bundled services index, and on the right we have the realized bundled services. So for instance, we can see that we have very high potential services here in the Amazon. Obviously we'll have a very high carbon value there, but because there are no people living there, we have very low realized services index there. So let's close that and have a look at some of the other maps. So we can look at relative threat. So this is threat according to accessibility, proximity to recent deforestation, change in population and GDP, climate change, and distribution of nighttime lights. And we can see that we have low values here along the coast and much higher values here in the Andean region and the Amazon here. The Relative Conservation Priority Index is a map of conservation priorities that is composed of an overlap of EBAs, Global 200 ecoregions, hotspots, last of the wild, IBAs, and KBAs. And I would be surprised if this does scale to 1, yes. So if this scales to 1, that means that all of these maps here or areas here are present. So we have some areas in this Columbia tile that are incredibly important for conservation, because they are part of all of these maps. So these are the conservation priorities. Now, if we then go up, we can combine the maps that we've seen before. So we can look at the areas that are pressured and threatened, where there is high realized service provision. So the relative aggregate nature conservation priority index based on realized services. So these are areas, just going back to it, that have high realized service provision, that are under pressure and are threatened and are conservation priority areas. So these are essentially the very important areas to focus on for conservation efforts. And then we have the relative aggregate development priority index based on the potential services, and we have a relative aggregate development priority index based on realized services. So these are areas that are pressured, but where there is low conservation priority and service provision. And so these are areas, again, where the conservation priority is low and relative realized service provision is low. And again, you can view those maps by aggregating them over other maps or by popping them out or overlaying them onto Google Maps. And you can have a look at the individual values here as well. Query, look at the inputs, query the inputs, and we can see that all the individual values at this particular pixel that I selected for the different services that we have in there, biodiversity index and the conservation priority index. Close that now. Now there's a number of other options here that are available to different user levels. So this means that you could overlay areas of interest by points or by zones, or you can do map analysis where you can get statistics of the map. Close this. Close the key output maps. As well as doing the baseline analysis, you would be able to do a policy exercise using the different user levels. So currently, because we are scientists, we don't have any of the intervention tools available to us. However, you would be able to run scenarios where you can change the priorities and values assigned to elements of conservation priority. You can do land use and land cover change scenarios whereby you can do deforestation, reforestation, etc., and see what impact that has on your ecosystem services. And finally, you also have the option to change input maps. Close that now. Finally, if you want to know more about the system, there is system documentation and model documentation here on the left, and that gives you a bit of background on how the tool works and how you should interpret the different outputs. So that concludes the demonstration of running a baseline in Trusting Nature for the scientist user interface. I hope that was useful. If you want to know more, check out the policysupport.org website. And if you're interested, you could sign up for one of our free online trainings or physical trainings in London as well. If you need any more information, you can contact us. Thank you very much.